Okay, so relatively easy. You need to understand how to solve for y. That's going to be a crucial part to today. Balance point, we move the x, we move the y. So I'm subtracting the x using inverse operations. Negative 5y comes down, equals negative 3x plus 10. I keep the x close to the equal sign because y equals mx plus b is slope-intercept form. Still with me there. Huzzah! I divide by negative 5. From everything, that leaves me y equals 3/5 x minus 2. Okay, so now we have slope-intercept form. Me personally, I say m equals, I say b equals. My slope is the coefficient next to the x. My b is the constant. So now I'm coming in. I'm saying 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4. Y-intercept is negative 2. Slope is positive, up 1, 2, 3, over 1, 2, 3, 4, 5. That's almost a straight line. Questions on that one? Okay, number 2. It's already there for me. M equals, B equals. Negative 4/5, positive 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there's positive 7. Down 1, 2, 3, 4, over 1, over 2, over 3, over 4, over 5. Ooh. That was actually a pretty good straight line. Don't roll your eyes at me. Don't roll your eyes. Questions on this? Okay. Go ahead and make sure you have this copied down, and then we are not in a review day, Mr. H. We are talking about systems. And it is by graphing today. Okay. Are we good here? Let's get out some notes. I'm not going to teach for very long. This lesson does not take a long time. You've already done it, but I want to explain why we do it. Okay. May I ask, what do your parents do, Eva? I know your dad's a...
My dad's an engineer. My mom doesn't have to work.
Okay. Lydia, may I ask what your parents do?
My mom's a speech pathologist, and my dad, I don't know what he does, but I know he works for Boeing.
Okay. Patrick, I know what your mom does.
My dad and life insurance.
Okay. Perfect. All three of your parents at some point have probably done something with a system. So, what is a system? A system is saying, I have a model that says it is doing this. Such as, in engineering, I'm going to go towards more my wife's. So, rockets. I know that if it goes up in space at this trajectory for this long, it will be here after so much time. Has anybody seen the movie, what was it called? Well, not Mark Wahlberg, Matt Damon, the Mars movie, where he's on Mars, he's the lone... The Martian, okay? Where they're talking about, how can we get this rocket to meet up at this time as he's shooting up here? There's two different equations that are happening. They're figuring out the equation of this rocket, and then they're figuring out the equation of this rocket to figure out exactly where they intersect, what's the exact precise point, okay? Your dad, you said your dad was doing what?
He works for Boeing.
Boeing, same idea. Planes versus all kinds of different things. The takeoff, the trajectory, the landing. Systems are what happens when we have two equations, but we're looking for where they intersect to form one specific point. Why? Because that one specific point, whether it's in time, whether it's in space, whatever, is the exact moment that we want something to happen. So again, I'm going to use that Martian. We've all seen The Martian?
Yep.
No? So Matt Damon's on Mars. It's a make-believe, but he's stuck on Mars. He's stranded. They've sent this other rocket ship to him, and he has something to blast off into space, and somehow they're going to catch him on this moving rocket as his rocket's moving up, and then they're going to jump out, and I mean, it's ridiculous. But this rocket's moving at a certain speed. They can figure that out. They can figure out how fast he's going. They have to time it up perfectly, or he keeps going, and then he dies in space, this rocket goes home, right? So, systems are often two or more equations that are going to intersect at one point. We are going to solve systems by graphing today. Okay? Graphing is the easiest way for most to solve a system. It's the easiest way to solve a system. But it is not the most accurate. Okay? Because we're graphing with our hands. If you are graphing and I ask you to graph 2.9437192, do you think that would be tough to graph? Like that exact point? Right? So it's tough to do that. So let's start off nice and easy. I'm going to give you guys these. This is your homework. Don't go, Gosh. You're really only going to have like 5 of them by the time that we're done. So we're going to do number 1. There are 2 equations that are already good for me. Y equals negative 5/3 x plus 3, and y equals 1/3 x minus 3. Now, when I say that the system intersects at one point, the one coordinate, the x comma y, has to work for this equation and has to work for this equation. If you can't substitute in the coordinate, the x comma y, of where they intersect into both equations, then it's not the answer. So, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. If you have colored pencils, great. If you don't, no worries. If you have no colored pencils, what I would do is I would name the lines 1 and 2. That way you just know. Okay? So I'm going to do red and green. It's going to be a Christmas miracle that I know how to do this. So my slope is negative 5/3. My y-intercept is positive 3. So my first line starts at positive 3. It's going down 1, 2, 3, 4, 5 over 1 over 2 over 3. Did I lose anybody yet? All we are doing in today's lesson is graphing both lines on the same graph and seeing where they intersect. So now I have negative 3 up 1 over 2 over 3. Do we have a place on that graph where and you guys actually have an actual graph, right? So like you should be able to see exactly where it's intersecting. Where, at what ordered pair do they intersect? So look on your graph, you guys just did it. At what ordered pair do they intersect? Negative 2, comma 3. This is the ordered pair where they intersect. If I plug in 3, negative 5/3 times 3, negative 5 times 3 is negative 15, divided by 3 is negative 5. Negative 5 plus 3 is, hold on, I did this wrong. It's backwards, Mr. H. Backwards, Mr. H. It's 3 comma negative 2. 3 on the x, negative 2 on the y. My fault. Still works. 3, negative 5 times 3 is negative 15, divided by 3 is negative 5. Plus 3 is negative 2. Oh, that works for x and y. This one, 3, 1/3 times 3 is 1, minus 3 is negative 2. Oh, it works for both. We know this is the exact answer. We know that's the exact answer. Yay for us. These are all very simple. But what is a great way to check it is with these calculators. So turn on your calculator. The very first thing we are going to do is press y equals, which is in the top left. William, it is here in the top left. You have y equals. We press y equals. We should come up to things where it says y1, y2, y3, y4. Yes? Does everybody see that? Making sure that we're all there. Okay. You there? Clear that up. Good. Okay, so right now we have y1, we have y2. You do not need to enter a y into the calculator because it's already y equals. So we are just putting in this portion. So let's enter in the first one. So I'm going to do -5 divided by 3. What x do I use? Does anybody know?
The one under link, right?
The one under what?
Link.
Link? I don't have a link button. Oh, yeah. So you should see the blue second button. Go over to where it says mode. And directly underneath that, you see a button that's an X, a T, a theta, and an N. Press that button. You now have -5/3 x. Okay, so you should have something that looks like this. Okay, so first, so we're putting in -5 divided by 3. And then see this button right here? The X, T, T. Okay. You're already doing the next one.
My bad.
No, you're fine. You see what you got? Yeah, 5/3 x. Good. Yep. Then put +3. So we have this equation. Press enter. It takes you down to y2. So now we're going to enter this one in. 1 divided by 3, x minus 3. So now we have both equations in there. Everybody with me? Okay, so right now we're going to press on the top, very top right, the word graph. And you should see 2 lines that have now graphed. Can you put it up here? Oops, sorry. I'm not staring down at your lap. Perfect. 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 Okay. So once you have them graphed, you're going to press your second button, the blue button. I think it's blue on everybody, maybe not. The second button. And then at the very top, you see the word trace. Above that, it says calculate. We're going to try to calculate something. Press calculate. So of those choices, which one do you think you're going to choose?
5.
What's 5?
And
We're looking for the intersect. So press 5 or move down. Oh man, it says first curve. What you want to do is get as, so you should see a flashing X. Okay, you see a flashing X. Does everybody see the little flashing circle with the X on it? Move it down to the intersection. So you with your right and left arrows, with your right and left arrows, with your right and left arrows, move it to the intersection. Put it as close as you can on that intersection. Press enter. Notice how at the bottom it says first curve. You press enter. It says second curve. Press enter. It says guess. Press enter. And then it gives you the intersection, which is 3 for x. Y is -2. Now, why is this good? Because remember, even though it has a graph, and we're pretty darn sure that it's 3, -2. And in this case, it is. What if it's 3.0000005, -1.99999? It would look pretty much the same on this, but this will tell you the exact answer. What questions do we have? All you're doing is graphing 2 lines. Okay? Let's try number 2. You guys try it on your own. Check it with your calculator. Go.
why is it freezing every class? I'm gonna crash out. Love my singing, everybody. Patrick, are you good? You were gone for like a week.
Yeah, I'm still feeling it.
Yeah, I can hear it.
Like I fell asleep in 2 of my classes already.
Oh my gosh. Wait, actually?
I fell asleep in my first hour and I almost fell asleep in my 3rd hour.
Patrick, you can't do that.
I am tired.
I think you should go home.
Had 3 bloody noses last night. In 2-hour concessions.
2 hours?
Yes.
It bled for 2 hours.
Yes, it bled for 2 hours.
Did you like lay down or like did you do anything to stop it?
I laid down.
Did you put your head up?
No, I put my head forward and closed.
That's why.
Yeah, you need to put it back.
So first, graph it. So graph it first before you, try to use the actual graph.
My bad.
The paper first, so you're gonna need to extend those. So I'm gonna take this, extend them, so that you can see where they're going to intersect.
Really why.
And guys, use a straight edge, use what you have. So what I mean by that is use like the edge of your calculator, use an edge of a notebook, something.
Hello. What? No, that's loading me now. Too much for like right now.
Oh yeah, I'm gonna put this.
Up one. Up one over two. Bro. I'm keeping my pencil down for too long. It's gonna look through. Yes, let me.
That's your
Why the music though?
Oh, okay, so we get like
What'd you do? Yeah, good job. We have the same.
do you think it would intersect that?
Alright, so we're both sick.
I got sick yesterday.
Not maybe go to Hawaii and Patrick. You're turning into Sean.
Oh my gosh, yeah, Sean's still coughing.
Okay, here we go. So, I'm not gonna graph it. You guys already graphed it. Based off of the graph, what'd you guys get?
Where do they intersect?
Yeah, we're
-2, 0.
negative 2, 0. Okay, so now I'm gonna go to y equals. All of a sudden, I still have my old two equations, right? So I need to clear those. So I can physically just press clear. So now I put in 4x plus 3, enter. Negative x minus 2, enter. I graph. And what did you say it was?
-2, 0.
Negative 2, 0. Because when I'm looking at my graph, that's not quite what it looks like to me. So when I plug them in, did you do them? So clear them out. Because I want you.
It's not negative.
No, mine's not either. So this is why we're checking it. 4
Negative 2.
x
Oh, yeah.
plus 3. Negative x.
Minus.
Not right there. Do you have them graphed? Ooh, that look. So now, once we're here, once we have the actual graph, we're going to press second, not table, Mr. H. Oh my gosh. Second trace. We press 5. Move the flashy thing down to the intersection. Press enter 3 times. And then it gives you our answer, which is -1, -1. It is no. That's that. I'm glad that you screwed it up. And here's why. No. Listen. Here's why. Because did you screw it up? No. You are human. No. Listen. You are human. You made your lines a little wonky, and you thought it was something different. Okay. But the calculator knows exactly where it's going to be. That's why I want you checking your answers with the calculator. You laughing at me?
So you're terrible.
Oh my gosh, I didn't. Don't do that to me. Don't do that to me. Okay, so now listen, flip it over. Oh, these are all pretty easy.
You're done.
Notice how these are all in slope-intercept form. Okay? They're already all in slope-intercept form. These are easy because you don't have to get them into slope-intercept form. There's going to be others that you will have to put into slope-intercept form before you put in the calculator. So, William, we are doing numbers 3 and 4, in case you want to pause that and use your calculator. Then we are doing numbers 5 and 6. And then we are doing, oh, move your hand, Mr. H. This is my Sparkle and Shine Band-Aid, just in case you're wondering. Then we're doing 7 and 8. Don't laugh at my Sparkle and Shine. I am as sparkly and shiny as possible right now.
Have you watched the show?
What?
Sparkle and Shine.
It's a show? No.
Oh.
Does it have a unicorn? Because that's what my Band-Aid has. Okay.
I thought you watched it if you had the Band-Aid.
No, it just says Sparkle and Shine. I don't think it's from a show. I just think it says Sparkle and Shine.
That is a
Like I'm like a unicorn with sparkling and shining. William, we miss you. Love you, brother.